about the different types of radioactive decay and the different types of radioactive particles. Now I'm going to teach you how to properly balance a nuclear reaction. Now, in my opinion, these are wonderful. They're not extremely difficult. They look scary, but actually knowing how to do them is pretty easy compared to some of the stuff we've done this year. So today, in this video, I'm going to be showing you how to balance a nuclear reaction, as well as how to determine what type of decay is occurring. So let's go ahead and get started. So, whereas before, when you were balancing chemical reactions, we had to count number of atoms, and we had to use coefficients to balance the numbers. Here, we can't count number of atoms because the atoms are going through transmutation. That means they're changing the identity of the element. They're actually turning from one element to another. So we can't balance the elements. Instead, we have to balance the top number, the mass number, and the bottom number. So either side needs to have a mass number and the atomic number match. So let's get started. So for this first one, we have 253 Es 99 plus helium. This is an alpha particle, yields a neutron, and we've got to figure out what's in the blank. So 253 plus 4 is 257. That means that this side has to equal 257 on the top as well. There's already a 1, so that means the top needs to be 256. Now, 99 plus 2 is 101. That means on this side, when we've got a 0 on the bottom, that means it's got to be a 101 on the bottom. Now, some of you might be thinking, how in the world do we know what element to write? You look at your periodic tables. You look at your periodic tables to figure that out. So when you look up 101, that's the atomic number. When you look that up in the periodic table, you find MD. And that's where it is. So use the bottom number to determine the actual symbol for the element. Now let's talk about how to identify reaction types. You've got to find your special particles. We're looking for alpha, we're looking for beta, or sometimes gamma. And we're seeing here, right there, there's our alpha particle. Now your reaction types always need to have two words. Alpha, and then what is actually happening. If alpha is found as a reactant, we call it bombardment. If it's found as a product, we call it alpha emission. This might also be alpha bombardment. It might also be absorb or absorption. Now these reactions don't tend to be as natural. In order for this reaction to occur, we have to bombard it with alpha particles. We have to shoot it with alpha particles to force the reaction to go. Okay, let's do the next one. 142 on the top, 142 on the top. So this needs to be a 0. On this side we have 61, on this side we have 60. So we have one too many over here. That means this needs to be a -1. Now what is that? That is an electron. Now I'm going to tell you, it would be incorrect to put a beta particle there. Why? Because beta refers to an electron that is being emitted. This is actually an electron being captured, and you know where that electron's coming from? It's actually coming from this nuclide. It's one of its inner electrons. The nucleus of this isotope is actually stealing one of its own electrons. Weird. Nuclear chemistry kind of breaks all the rules we thought were possible. So this one would be electron capture. Let's do the next one. 187 on the top, on this side. 189. That means we need 2 more over here. So 2 on top. 76 over here. 75 over here. That means we need a 1 on the bottom. We use the bottom to figure out what element that is, and that is definitely hydrogen. So in order to identify this one, ooh, hey, here's a case in which you don't really need to know the reaction type for this one because this is not one I taught you. So the few that I taught you are not the only possibilities. This is not one that you would need to know. Okay, let's do the next one. We've got boron, 8 and 5, so 8 on top, 0 on this side, so this needs to be an 8. And then we have 5 over here, that means this side needs to add up to 5. So we've got 4. Look at your reference table, look at your periodic table, find atomic number 4, and that's going to tell us the identity of this element, and that is Be. Now, find your very important, right there is our particle. Now, academic kids, that one's strange, isn't it? It's called a positron. It's technically a positive electron. Ooh, weird. Academic. Let me repeat. Academic students, you don't need to know this type. Honors, definitely you do. So honors folks, you would need to recognize this as positron, and we always need 2 words. Emission. Positron emission. Because it emits a positron particle. Okay, let's do the next one. 131, 131, so the top needs to be 0. 53 and 54, so we have 1 too many over here. That is a -1. Now, there are 2 ways you can write this. This is a beta particle, so you can definitely write the capital B. It would also be okay to write the E. I will tell you it'd also be okay to write the E here too. But you cannot write a beta here because a beta particle's definition is an electron that's being emitted. In this case, it's not being emitted, so that is not a beta particle. So there is our special particle that's going to help identify the reaction type. And this one is beta, and you always need a second word, beta emission. Last one, 22 and 22. So the top is already balanced. The bottom, 11 and 10, -1. Ooh, this one's electron capture yet again. So the only reaction type I did not include in my example would be alpha emission. That would be where there's an alpha particle as a product. But I think I showed you all the others that you need to know. And don't be scared if you end up seeing a reaction that does not have one of the particles that we recognize, because definitely these 4 plus alpha, these 5, plus the alpha emission aren't the only types of reactions out there. So there is one more type of problem I want to show you, because this is just fill in the blank and identify the reaction type. But you might also see it in sentence format, and these you've got to go a little bit more into detail. So this one says, write the balanced nuclear equation for the alpha decay, alpha decay of thorium-210. Alpha decay is another word for alpha emission. So although I didn't show you an example of this over here, you're going to see one now. Alpha emission. So write a balanced nuclear equation for the alpha decay of thorium-210. Thorium-210. Now where do you get the bottom number? You look it up, And I believe it is 90. And alpha emission means that it's going to emit an alpha particle. So we know that an alpha particle is going to be a product. But now we have to balance to figure out the other one. So this would be 210 minus 4 is 206. And 90 minus 2 is 88. And in order to get the actual element, we'd have to look at our periodic table. So go ahead and grab your periodic table and find atomic number 88. And when you look that up, when you look up this atomic number in your periodic tables, you get radium, Ra. And right here, that is the key particle that tells us it's alpha emission. Remember, when you see alpha or beta decay, that is referring to alpha or beta emission. So that means that those particles are going to be products. So not too bad, right? Thank you for watching this video.